Imagine drifting through space. No engines, no sound, only stars, frozen against a black sky. Ahead of you is something darker than darkness itself. Not a hole in space, but a hole in reality. A black hole. It doesn't glow, it doesn't roar, it doesn't chase. It simply waits. And once you cross a certain invisible boundary, the universe will never allow you to leave. Tonight, we're not exploring science fiction. We're following physics, step by step, into one of the most extreme environments nature allows. What would really happen if you fell into a black hole?
A black hole
Is not an object in the usual sense. It's a region of space-time where gravity becomes so intense that space and time themselves collapse inward. It begins with a massive star. When nuclear fusion ends, the outward pressure disappears. Gravity takes over. The core collapses. Atoms are crushed. Electrons merge with protons. And if the mass is great enough, nothing halts the collapse. Not pressure, not light, not even the structure of space-time itself. What remains is a singularity, a point where density becomes infinite and our equations lose meaning. Around it forms the event horizon. Not a surface, not a wall, a boundary in time. Once crossed, every possible future points inward.
from a distance.
A black hole feels ordinary. Its gravity follows the same laws as any massive object. But as you fall closer, reality begins to stretch. According to Einstein's relativity, gravity slows time. The stronger the gravity, the slower time moves. To a distant observer watching you fall, your motion appears to slow. Your clock ticks more slowly. Your movements stretch longer. You never quite reach the horizon. You fade, you freeze, you redshift into darkness. From the outside, you seem trapped in a final moment. But that is not what you experience.
From your perspective,
Nothing feels unusual. Your thoughts flow, your heartbeat remains steady. Time behaves normally, for now. You cross the event horizon without noticing anything special. No flash, no shock, no warning. That's the most unsettling truth, because once you cross it, there is no path back. Inside the event horizon, space and time exchange roles. Moving forward in time means moving toward the center. Stopping is no longer possible. The future has only one direction. As you fall deeper, gravity becomes uneven across your body. Your feet feel stronger gravity than your head. That difference stretches you. Slowly at first, relentlessly. Your body elongates. Your cells separate. Your molecules unravel. Physicists call this spaghettification, not because it's humorous, but because it's precise. For small black holes, this happens quickly. For supermassive ones, much later. Which means something unsettling. You could cross the event horizon intact and only be torn apart far deeper inside. Inside the black hole, light behaves differently. Photons curve inward, paths bend back on themselves. There is no outward direction. If you shine a light forward, it still moves inward. If you look behind you, you no longer see the universe. The universe has already moved on. Seconds outside stretch into years, years into ages. From your frame of reference, the distant future of the cosmos may pass before your fall ends. Stars ignite and fade. Galaxies drift apart. Darkness spreads. And still, you continue inward. One of the deepest questions in modern physics is this. When something falls into a black hole, Is its information lost forever? Quantum mechanics says no. Information cannot be destroyed. General relativity suggests otherwise. This contradiction is known as the black hole information paradox. Some theories say information is stored on the horizon. Others suggest it leaks out through Hawking radiation. Some propose connections to other universes. We don't yet know which, if any, is correct. And that uncertainty marks the boundary between what we understand and what still lies beyond us.
At the center
Lies the singularity, a place where space collapses into zero volume, where time loses meaning, where equations return infinity. No signal escapes this region, no experiment can reach it. Our physics ends here. What happens to you? We don't know. And that answer, we don't know, is not a failure. It is the edge of knowledge itself.
black holes are not cosmic monsters.
They do not hunt. They do not destroy at random. They reveal. They show us where space bends beyond intuition, where time breaks its familiar flow, where our understanding runs out. Somewhere in the universe right now, black holes quietly shape galaxies, stretch time, and guard secrets older than the stars.
If you've made it this far,
You followed physics to one of the deepest limits of reality. Thank you for watching until the end. And thank you for exploring the universe with AstroNerd.